Okay, so in this first lecture, I will introduce you to the classical linear regression or econometric model, especially for those that haven't learned econometric or regression before. Okay, so what is econometric? So econometric is a method or technique that allow us to use sample data on observable variables to learn about economic relationship or the functional relationship among economic variables. Okay, so it helps us to assess or to measure or to identify the existence of relationship between different variables. And then the variables that can be used to construct economic model is not necessarily economic variable, so it also can be used for other than non-economic variables. So econometric consists mainly of two things. The first one to estimate the estimation, and then the second one is to test or to perform the hypothesis testing. Okay, so it consists mainly of the estimating economic relationship from sample data, and then testing hypothesis about how economic variables are related. So basically, we would like to know or to estimate the effects of what we call that other one variable to other variables, and then we also want to perform hypothesis testing on in order to identify whether in terms what we call that the effect is statistically significant or not. So there are three empirical attributes of a relationship we are concerned with testing. So the first one, in terms of the existence of relationship between a dependent variable and the independent variables that are thought to determine it. So we would like to know whether a relationship exists between dependent and independent variables. So in this case, dependent variable we also call it as what we call a response variable. And then the independent variable, we also call it as explanatory variable. So we use independent variable or explanatory variable to explain the dependent variable. So normally we denote the dependent variable using Y symbol, and then independent variable we use the X, okay, but not necessarily Y and X. You also can use other symbol, but the common symbol used to represent dependent variable is Y. And then independent variable is we use X, X1, X2, X3, and so on. And then the second one, if the relationship between Y and X exists, we also would like to know the direction of the relationship. So the direction of the relationship between one economic variable, the dependent or outcome variable, and its hypothesized observable determinants. And then the magnitude of the relationship between a dependent variable and the dependent variable they are thought to determine it. So we would like to know, first we would like to know whether the relationship between dependent and independent variable exists or not, and then if exists, the direction, whether it is positive or negatively related. Okay, so if positively related means that when X, that particular X increase, the dependent variable Y also increase. And then if the direction is negative, so when that particular X increase the value, and then it will make the Y dependent variable to be decrease, the values of Y to be decreased. And then we would like to know the magnitude, how large the effects of each of X on Y. So in order to what we call that, to find out each of these, then we need to have a sample data, because most of the time we do not have what we call the access to the entire population, so that we need to what we call that, to estimate, to perform analysis using sample data. The sample data consists of observation on randomly selected members of population of economic agent, so either individual, person, household, or families, or firms, or other units of observation, industry, provinces, or states or countries. Okay, so the role of econometric is provide measurement and quantitative analysis of actual economic phenomena or economic relationship based on three things: the economic theory, economic data, and method of model constructed. First, so you need to refer to the economic theory first. I mean, on how the theory suggests the relationship between Y and X, and then you need to what we call it, to acquire the data, and then you need to have a method to construct the model. So the aim of econometric modeling, first we would like to explain the relationship between y and x, between dependent and independent variable. And then we also use econometric for policy evaluation. So let's say, I mean, we want to know whether X really influence Y or not. So let's say the independent variable in this case is the interest rate, for example, and your dependent variable is money supply, for example. So we want to know how we can, what we call that, we can change the value of interest rate in order to what we call that, to change the value of the money supply. So by using econometric models allow us to evaluate whether if we, let's say we increase the interest rate by 1%, I mean how it's going to influence the money supply or other economic variables. And then we also want to use the econometric model to do prediction. So we want to predict what's the value of R or Y, independent variable, for a given value of independent variable. Okay, so basically econometric analysis help us to combine economic theories and the economic data to find answers. So we do have economic theories and then we do have data. So using econometric, it helps us to use information efficiently. Okay, so that you can find what we call the economic findings so that we can understand, explain, interpret, predict, or even forecast the relationship between economic variables and formulate policy. So consider this example. Let's say we would like to construct a model for consumption. So given by C, so C is some function of income. So C is a function of income. So for applied econometric analysis, this consumption function must be specified more precisely. So let's say we use demand as a proxy for consumption. So let's say our dependent variable is demand for individual commodity. So we need to specify all the important factors affecting the demand. So the demand is a function of P, PS, and Y. So P is the own price of that product or commodity, and then the PS is the substitute, the price of substitute items, and then Y is income. So you need to specify what we call that all the possible factors so that you can include all these factors in the model. So in this case, dependent variable is the demand, and then independent variable is the price, substitute price, as well as income. Okay, and then based on from the theory of assumption, so we know that based on law of demand, then we know that when this is what we call as our prior expectation. So how the relationship between the two variables exists between demand and each of these variables or determinants of factors. So when the price increase based on law of demand, then we know that the demand will be reduced, okay, decreasing. And then based on definition of substitutes, what we call that when the price of substitute commodity increase, and then the demand for this, what we call that commodity is expected to be increased as well. Okay, because it encourage, because the price of the substitutes, the substitute product, the competing product is increased, so that it will encourage people to buy this commodity, so that the demand is going to be increased. And then the last one, the income, when income increase, and then the demand also increase. So these two for normal product, normal goods or normal product. So for what we call that certain product, especially for the cheap product, then this is not really true, because when the income increase, then people tend to buy more quality, the quality with better quality product. Okay, so that in that case, when income increase, then it will reduce the demand for that product. But for most of the product, other normal goods, then when income increase, it will increase the demand for that product. So this one is our, the second attributes, the one that I explained before. So now the next question is by how much, if the relationship exists between variables, between the demand and each of these, what we call that determinants, then by how much. So listing the variables in economic relationship is not enough. For effective policy, we must know the amount of change needed for a policy instrument to bring about the desired effect. So for example, by how much should the Bank Negara Malaysia, the Central Bank of Malaysia, raise or cut interest rate to prevent inflation or recession. So in this case, we need to know by how much. So you need to estimate first, estimate the model, and then you will know by how much. So when the interest rate increase, then we what we call that, we predict how much the inflation what we call that decrease. Okay, decrease or increase. So the relationship between the two variables. Okay, and then for another example, by how much can the price of football ticket be increased and still fill the stadium? So in this case, we would like to know the what we call that the magnitude of effects, the magnitude of relationship. In this case, by how much we should the price, what we call that, we should reduce the price of the what we call the ticket price, so that we can have what we call the higher number of what we call spectators. Okay, so to fill the stadium. So in order to answering the question of how much, so we need to estimate parameters that are both unknown and unobservable. So I mean the true value of relationship between y and x, it is something that unknown. Now we do not know the true value, and also unobservable, we cannot see. So what we need to do, we need to estimate. Okay, so using statistical model to estimate the average, or to compute the average or systematic behavior over many individual or many firms. Okay, so this is our estimate. So by taking the average or systematic behavior over many individual will help us to estimate the relationship between the amount, the magnitude of relationship between what we call that the y and x, between dependent and independent variable. So in this case, because we estimate, we compute the average. So this does not represent the true value of the response variable. So this gives us estimate of prediction. So there will be what we call that different discrepancies between actual and the predicted value. So in this case, our example consumption. So the actual is the actual value of the consumption, so the demand, and then by taking average, okay, the average of systematic behavior, it gives a prediction. So there is a predicted value. So the predicted value is not, most of the time that it is not exactly the same value of the actual value. Okay, so it's possible. It's also possible that it is exactly the same value, but most of the time it is different. Okay, actual value and predicted value are different values, so that the difference between the two represent our prediction error. So we call it as a random error. So this one, the error must be random. So that's why we call it a random error. So the difference between actual and the estimated or predicted value represent our prediction error or random error. So in this case, consumption C, for the given example, is a function of income. So with error. Okay, so this one error or disturbance, we call error or disturbance. So is the so consumption C is the function of income plus the error term of prediction error. Systematic parts provide prediction. So given by this function of income, but actual we miss by random error. Okay, now we need to, so this is what we call as, this is an econometric model. So because we have the estimate plus the error term, and then need to identify, we need to define the function of income. We need to define the function for the systematic component and systematic part. In some way to make consumption, see a linear function of income. So let's say we consider a linear function. But in equation model, it's not necessarily linear, so it's also possible. We also can use what we call that non-linear equation for the systematic part. So in this case, for the given, so in this case, the function of income is given by, because we decide, let's say we decide to use a linear equation or linear function, so that we need to have, it just like what we call that, we need to have intercept, and then we have slope times the, what we call that dependent variable. Okay, so this is what we call mathematical model. So if we assume this is exactly the same value to this one, then so this equal to this one, then we call this mathematical model. So in mathematical model, it represent, I mean, the value for the right hand side of the equation and the left hand side of the equation is are exactly the same. But in econometric models, so as I mentioned just now, most of the time we won't have exact value. When we make prediction, it's not exactly the same or equal to the true value. So we need to have an error term in the model. So we call this as an econometric model. So then the statistical model becomes this one an econometric model. So because we have the prediction plus the error, the prediction error. Okay. So again, the actual value minus the predicted value, will give us the error, prediction error. So this is what we call as econometric model. So in the econometric model or regression model, if we only have one independent variable, so the model is written like this. So y equal to an intercept plus the slope coefficient beta 1 times x plus the error term. So this is what we call a simple regression, where the equation only has two variables, one response variable and one independent variable. So the source of changes of y is from the variation in x. So in this case, dependent variable y is the focus of the study. And then exponential variable x help us explain observed changes in the dependent variables. So in this case, beta 0 is an intercept or constant, and the beta 1 is the slope parameter. So we can add more independent variables, and then we call it as a multiple regression model. So this, when we have more than one independent variables, then it becomes a multiple regression.